Welcome back to Concepts in Arithmetic. In this video we are going to demonstrate some techniques useful for doing mental math. So the key idea is using compensation to make tens, or at least multiples of tens. And that takes advantage of the place value system. If you can turn your problem into one that deals with multiples of tens, you basically turn a two-digit addition problem into a one-digit addition problem. So let me explain what I mean right here. And this is something we actually discussed in a previous video as well. But if I was to add 37 plus 49, what we might do is we'd say, okay, that 49, that's pretty close to 50. Okay, so we would take 1 away from this, and we would turn this into not 37 plus 49, but 36 plus 50. And then we do the computation and get 86 as the answer. All right, here we look at this, and we might say, okay, well, this is pretty close to 60. Let's take 1 away from this and put it over there. All right, so we'll take a 1 and move it that way. That makes this 330, that makes this 60. So let me see, what do we get? We get 390 as a result. Okay, now of course these are using the operation of addition. And we can equally well do mental math with subtraction problems. You got to be careful though, okay? It might be tempting to say, okay, this is close to 20, so I'll do the same trick I did over here, right? We had something close to 50, so I took 1 away and then I added 50. So suppose I do this, right? Suppose I take 1 away and then subtract 20, okay? Now, that is tempting, but it is wrong, okay? You got to be careful. All right, this is starting with something smaller and taking away more, so you're going to get less. Okay, you can't do it like that. This is the way I usually think of it. Okay, it'd be really nice if I could take away 20, but I only want to take away 19. So what I do is I start with the 58. I do take away 20, and then I throw 1 back. Okay. So 58 take away 20, you're at 38, throw 1 back, and you have 39. Okay, and you can see here this would get us to 37, so that is not getting us the right answer, so it's not the way to do the problem. Okay, so no, no, no on that. Okay, so when I think of compensation for subtraction, that's what I do. So here, very similar procedure. 84 take away 20. You got 64. Throw 1 back. You got 65. So in other words, I'm viewing subtraction of 19 as subtraction of 20 and then adding 1. And what did we just say? 65. Okay, great. All right. Taking away 48. What would we do? Okay, well, we would take away 50, and then throw back 2. Okay, the whole reason we took away 20 was that it makes it a one-digit subtraction problem. Okay, you want to do the same thing here. It's not going to make it any easier if you take away 49. If you're going to do that, you might as well just subtract the 48 right away. But if you subtract 50, 76 minus 50 is 26. Throw back the 2, and you get 28. Okay. An alternative to this, and let me scooch over here. An alternative, let's say on this last one. Okay, we're dealing with 76 minus 48. Is to kind of slide everything up by 2. You want to make that a multiple of 10, you go to 50. So you had to bump it up by 2. Well, you got to bump everything up by 2. Okay, 78 minus 50, and you're left with 28. And you can see that's the right answer, so that's a way to do the problem. So that's another way to think about compensation when you're doing a subtraction problem by mental math. If you slide one thing up, you got to slide the other thing up too, so that you keep the same distance between the numbers. Because remember, subtraction, the result of a subtraction is in fact called the difference. So if you do this procedure, this failed procedure, what you're doing is you're moving this end closer, you're moving that end closer. So what happened to that gap? You squeeze the gap down. You have changed the difference. Whereas if you just move the whole thing, the difference has stayed the same. It's just in a different spot. Okay, so that's one way to do it, but I often just think of, if you're taking away 19, just take away 20, which is easy, throw one back to compensate for your actual answer.